Homework 2.4, more on slopes, video 3. Homework due Friday, May 22nd, 2020 at 11:59 p.m. Perpendicular lines. At the end of the previous video, I meant to ask the question, what do you think the opposite of parallel is? And that usually tricks a lot of people into saying perpendicular, which isn't entirely true. Because I can draw two parallel lines, two lines that aren't parallel but aren't perpendicular either. And by the way, do you know what it means to be perpendicular? Perpendicular lines make a right angle. So for example, a vertical line and a horizontal line are perpendicular, but they don't have to be horizontal or vertical. As long as they make a right angle between them, they are perpendicular. By the way, the opposite of parallel is intersecting. Think about it. Perpendicular lines are just a special case of intersecting lines because they meet at a 90-degree angle. So we're going to do some problems similar to what we did in the previous videos. For example, find the equation of the line that passes through the point 6, 5 and is perpendicular to y equals 1/4 x plus 11. And we're going to answer this one in slope-intercept form. Answer in slope-intercept form. In order to do that, we have to know the relationship between the slopes of perpendicular lines. And one thing I've noticed as I've been making these videos is I'm taking advantage of the fact that I'm not limited by time in a classroom, and therefore some of the videos are running longer than I wanted, as evident by the total viewing times listed on the modules. So my apologies if those times are a little bit intimidating, but it is what it is. And so in an effort to cut back on that, I'm going to cut out some of the things I would normally do. For example, I can go through a situation and get you to tell me the relationship between the slopes of perpendicular lines, but I'm just going to tell you. Perpendicular lines have opposite, meaning one is positive and one is negative, but there's more reciprocal slopes. Reciprocal meaning you turn one of them upside down as a fraction to get the other. So if you know the slope of one line, you can get the slope of a perpendicular line by doing two things: changing its sign and turning the fraction upside down. For example, let's say we had the line y equals 8/13 x plus 92. Could you give me the equation of a perpendicular line? Well, the slope of this line is 8/13, and so the slope of a perpendicular line would have an opposite slope, so it would be negative, but also reciprocal, so it would be 13/8. So negative 13/8, x, we'll say minus 117. The intercepts are actually irrelevant because the intercepts do not determine if they are parallel and perpendicular. It's all about the slopes. So in the previous two examples, if you were wondering why I never used the y-intercept once I got to slope-intercept form, it's because I didn't need it. Parallel and perpendicular is all about slopes and nothing about intercepts. In the back of my mind, I know there's an exception. Parallel lines must have the same slope with different intercepts, but let's not worry about that. So these two lines would be perpendicular because their slopes are opposite signed. One is positive, one is negative, and reciprocals, 8/13, 13/8. So let's answer this one. If we're going to build the equation of a line, we need a point and a slope. We already have a point, we need a slope. So what do we know about the slope we want? We want the slope that is perpendicular to this slope, which means opposite reciprocal of this slope. What is this slope? Well, this equation is already in slope-intercept form, so its slope is 1/4. That means that the perpendicular slope has the opposite sign, so it's negative, and is the reciprocal of 1/4, so 4/1. Oh wait, negative 4/1, that's just negative 4. So the perpendicular slope, the one that we want to use, is negative 4. So I'm ready to build the equation. With the perpendicular slope of negative 4, and sometimes what you'll see is an m subscripted with the perpendicular sign, which looks like an upside down capital T. But with the perpendicular slope of negative 4, our point slope form would be y minus the y coordinate, so y minus 5, equals the perpendicular slope, -4, times x minus the x coordinate, so x minus 6. And since we want the answer in slope-intercept form, we need to solve this for y and get rid of the parentheses. No fractions here, hooray. Y minus 5 equals -4 times x is -4x. -4 times positive 6 is positive 24. And now we just have to add 5 to both sides. And if we add 5 to both sides, we will get y equals -4x plus 29 as our line that contains the 0.6 comma 5. We could check that easily by putting 6 here. -4 times 6 is -24. -24 plus 29 is 5. And has the perpendicular slope because it is both opposite in sign and the reciprocal. Oops, I forgot to mention that in homework 2.4 you should try questions 2 and 4. We're going to do one more perpendicular line video, and then there will be one more short video after that, and this section is over.